So our next problem here is number 4, and we start with the given, right? We have line segment PR is congruent to line segment QS. So we start with the given here. Line segment PR is congruent to line segment QS, given, right? Now what is our steps on writing a proof? The first step is to turn any congruency statements into equations using definition of congruent segments. Right? Second step is, if any midpoints are given, use the definition of midpoint to create more equations. Third step, if you have 3 points on a line, use segment addition postulate to create more equations. First part of the segment plus second part of the segment equals the whole segment. And remember, if you're given 4 points on a line, use seg_add_post twice, right? First on the first set of 3 points, and then another time on the second set of 3 points. So anyways, our first step is to turn any congruency statements into equations. So we have a congruency statement. It's right there. It's given. We turn him into equation, like so. Notice the line over PR goes and QS goes away. Now we're talking about measure of PR is equal to measure of QS. That's the definition of congruence. It lets us go from congruency statement to equation. Okay. Now what do? Now we are to see, do we have any midpoints? Is it given that Q is a midpoint or R is a midpoint? No, it's not given here that Q is a midpoint or R is a midpoint. So we skip that step. Third step is now to look at the figure and say, can we apply seg_add_post? Do we have 3 points on a line? Yes, we have 3 points on a line. Not only do we have 3 points on a line, we have 4 points on a line. Okay? If we have 3 points on a line, like here, you do seg_add_post. AB plus BC equals AC. First part of the segment plus second part of the segment equals the whole segment. Right? But if you have 4 points on a line, like we have here, right, then what do? We apply seg_add_post to the first 3 points, those 3. PQ plus QR equals PR, the whole thing. And then we do seg_add_post on the second 3 points. We say QR plus RS is equal to QS, the whole thing. And that's what we're going to do. So here we have PQ plus QR is equal to PR. That's using seg_add_post on the first 3 points, right? Seg_add_post. Then we're going to apply seg_add_post on the second 3 points. It's QR plus RS is equal to QS. First part plus second part equals the whole part, right? Seg_add_post. Now what do? Well, we've created all the equations that we can, right? And now the last step is substitution. Substitute to get to this proof statement that PQ is equal to RS. Now how do we do that? Well, if you look here, right, we have 3 equations. We got B, C, and D. So what can we do? Well, what this equation here means is anywhere I see PR, I could put this expression right here. Right? So do you see PR anywhere? And yeah, you might be thinking, yeah, PR's right there, right? But you don't substitute into the same equation. So is there another equation? Is PR here? No, PR is not here. Is PR up here? Yes, PR is right there. So I'm going to take this expression, what PR is equal to, and I'm going to put it right in there in the place of PR. Now, down here, I have this expression, QR plus RS is equal to QS. That means anywhere I see QS, I could put this expression, QR plus RS. And do I see QS anywhere? Do I see it here? No. Do I see it up here? Yes, I do. It's right there. So I'm going to take this expression, and I'm going to put him right in there. I'm going to take this expression, and I'm going to put him right there. Right? Substitute both of those into equation B. And that's how I get equation E. Okay? And the reason is substitution. Now, what do I need? I'm trying to get PQ equal to RS. So I need the QRs to go away. Luckily, that's easy. I just subtract the QR on both sides. So I do PQ plus QR minus QR is equal to QR minus QR plus RS. Subtraction property lets us subtract the same number, QR, measure QR, from both sides of the equal sign. Now what do? Now I go ahead and get rid of the QRs. Okay? So I'm going to say PQ is equal to RS. And the reason is going to be substitution. Okay. What did I do? I substituted QR minus QR for what is equal to 0, and I substituted QR minus QR for what it's equal to 0. Right? And then lastly, I don't want an equation. I want a congruency statement. So I'm going to say line segment, the line comes back congruent to line segment RS, and I get my proof statement. Oh, and then that is def of congruence.